So today's session will be on overview on automotive BIW. So we'll go through one by one. First of all, what is the agenda? So for today's agenda will be on 4 topics. What is BIW, components of BIW, design consideration, and material selection. So we'll be, and there are some subtopics which will be going on the go. What is the types of BIW and what are the major things that define the material selection. So those are the subtopics which we'll be going through. So what is an automotive BIW or what is an automotive body? So to be blunt and straight to the point, automotive body consists of metal components basically. And these metal components can be sheet metal, forging components, casting components, etc. So mostly automotive body comprises of the 20 to 30% weight of the automotive. That is, if you consider a car, 20 to 30% of the weight of the car depends on the automotive body. And why do we call it as a body in white? Generally in industry or automotive, any automotive industry, if you go, automotive body will be called as body in white. So that is because, like, when you see an automotive body, once it is made, it will be quite white in color, like a pale white in color. So that is the reason most of the terms it is called as body in white. Okay. So there are 2 different types of automotive body majorly which we use, that is body on frame and monocoque. So let's go into these types one by one slowly. So what is body on frame? So body on frame consists of a separate frame which forms the base of the vehicle. So on this frame mounts the major heavy components like engines, tires, suspension, and so on. So above this frame, again, there will be a complete body which holds the passenger compartment is mounted. Okay, so this type of constructions are used for heavy vehicles like pickup trucks and heavy load SUVs and so on. So this is the primary, this is the major construction type which automotive vehicles were initially using. So later came the monocoque construction, and this monocoque construction was primarily used on ships and aircraft manufacturing. So we took up this concept from aircraft manufacturing and ship manufacturing and tried to integrate an automotive where there will not be a separate frame. So only a complete body and all the components, interfaces like engines, wheels, suspensions, everything gets mounted on directly to this body. So this type of constructions are used on sedan and some off-road vehicles. And if you see racing cars like F1 cars and so on, so they are made up of this type of constructions. So these are the major 2 types of automotive body constructions which are used in the industry currently. So the next topic will be BIW components. So when we say an automotive body or automotive BIW, what are the major components in them? So there are 3 major divisions in them. So one is underbody, the other is upper body, and the last one we call it as the closures or the door components. Okay, so if you go for an underbody, the underbody consists of hope my pointer is visible. So when we go for an underbody construction, so we have 3 major components: engine compartment, front floor, and rear floor. So engine compartment is nothing but the front end area where the engine and other components gets mounted. So front floor is nothing but the component which defines the front compartment or the driver compartment of the vehicle. And the rear floor defines the rear compartment if the vehicle has a separate passenger compartment after the driver compartment. So all these components combined together forms the underbody. All 3 together forms the underbody. The next one will be the upper body. Upper body is defined as body side and the roof. Body side is nothing but the exterior left side and exterior right side of the body and the top roof of the body. So all these three combined together forms the upper body components. And closures, as I said, they are the door components, which include the side door, the hood or the front bonnet, and the tailgate or the trunk lid, whatever it is. So all these components combined together is called the closures. So now all these three major components will form the body in white for an automotive structure. Okay. So in any automotive industry, if you go, they will be following this construction structure for the body in white for development or design or anything. Okay. So we have understood what are the major components in the BIW of an automotive. So now, what are the design considerations we are supposed to take? There are 5 major design considerations which we'll have to take into account when we are designing an automotive body. First one will be the aesthetics. Second is the aerodynamics. Third is the design for concept, like what sort of concept we are designing the vehicle for. Next is design for manufacturing and design for safety. Okay, so what is aesthetics? So aesthetics is nothing but convincing the customer's visuality. So when a customer goes to say automotive company or an automotive dealership to see a vehicle or purchase a vehicle. So what is the first thing that the customer likes is the aesthetics of the car. So first thing what we'll have to do is when we are designing a body, we'll have to try to design the body such that it pleases the customer to purchase the automotive or the vehicle. So next comes the aerodynamics. So aerodynamics we take into consideration for the fuel efficiency and better vehicle stability on the road. So aerodynamics will be taken into consideration at the first stage where the styling of the vehicle is being designed. So next is the design for concept. Say for which concept are we designing? So if you say like there are different concepts of vehicle or different models of vehicle, sedan, SUVs, coupe, crossover coupe, and in those also we have IC engines. Now we have electric cars. So, and what are the materials we are going to consider in them? What are the interfaces or the technologies we are going to use in that vehicle? So all these, each and every small bits and pieces of the concept will be taken into consideration during design of a body. So next is design for manufacturing. Say we are designing a sheet metal component for an automotive body. That part, in order to put that part in a body in a car, we need to find out whether the part will be manufacturable. So if a part has to be manufacturable, while designing itself, we have to take the inputs of the manufacturing into consideration so that we can manufacture the component and bring it as a physical part and then put it in an automotive industry. Put it in an automotive component or body design. Okay. So that is where manufacturing comes into play. And next is design for safety. Say, for example, I said the car is made of sheet metal. So since it is made of sheet metal, we just cannot make only bending operation or a flat sheet plate and put it and say, okay, I have designed a car. So there is the next aspect which comes, that is the safety of the passenger and the exterior environmental passengers as well. So we'll have to consider both, like whoever is outside the vehicle and whoever is going to be inside the vehicle have to be safe. So each and every component that we design in an automotive BIW must have a consideration of the safety standards, safety regulations required for the particular market where we are designing. So for each and every country, for each and every location, the safety standards differ. There are different standards like Indian standards, European standards, US standards, and all these standards differ for different countries, and there are different regulation under these standards which we'll have to clear if we want to sell a particular vehicle in that market. So those sort of design safety considerations also will be taken into account while designing a body. So there are various safety standards like frontal crash, side intrusion, and offset frontal crash, say pole impact. and rear impact, side impact. So all these regulations has to be taken into consideration while designing a body. And the body has to meet the safety standards such that it protects the customer inside the vehicle and outside the vehicle. Okay. So now we know what are the design consideration we are supposed to take. So we'll move further for the material selection. So as I said, majorly the automotive body consists of metals. So there are various metals which are used like steel, aluminum, FRPs, and so on. So majorly automotive parts consist of steel components and a minimum like kind of 30 to 20%, 20 to 30% of steel, and about 50% of aluminum composites or aluminum alloys. Aluminum alloys majorly we discovered in recent times where we are able to reduce weight. So majorly we go for aluminum for reduced weight, but at the same time we can maintain a compromised strength and stiffness alongside of steel. And FRPs are nothing but fiber reinforced plastics which we use for much weight reduction wherever there is no requirement of stiffness or like what is it? There is more requirement. There is no requirement of strength, but there's only requirement of stiffness and so on. In those areas, we use FRPs to add only stiffness and reduce the weight. So these are the major material which we use in automotive BIWs. So now we are going further into material selection. So as I said, there are two different types of modeling. One is strength-based modeling and another is stiffness-based modeling. So strength-based modeling is based on the material properties or mechanical properties of the material that we select. And stiffness-based modeling are based on the shape of the component that we are designing. Okay, so the when you consider strength-based material, the strength of the component can be improved by changing the thickness of the material or the material of the component. Okay, say for example, we are going with, say, first we are going with aluminum composite. So we are finding that the material is not giving the strength what is required to clear the CAE or the analysis. So at that time, what we suggest is we will go for a pure steel component or a higher grade material, or we'll increase the thickness of the same component and we'll try to meet the CAE. So that is strength-based modeling. So what is stiffness-based modeling? So here what we do is we try to change the shape of the component. Say for example, initially we have made a shape like what we see in see at Mechatronics, right? So whatever the shape is there in 3, we have made that structure initially and it is not meeting CAE. So what we do is we change the shape. We change it to shape number 4, or either we change it to shape number 2. So we try changing the shape instead of changing the material and thickness. And we'll try to do the CAE and we'll try to meet the CAE. So this is the major difference between strength-based modeling and stiffness-based modeling. So at times we will be able to meet the CAE just based on stiffness-based modeling itself. So it's a very rare case we go for strength-based modeling where we change the material to a higher grade or so on, because the higher grade materials are of high cost and the availability of those materials are not guaranteed in the future. So that is the reason we try to avoid strength-based material on a longer run of cycle. So we go for stiffness-based modeling at max. So this is with respect to the material selection. So next will be the CAE DVPs. So when it comes to material selection, the major thing which impacts the material selection is the CAE. So as I said, when a vehicle is being designed, each and every component which is being designed in the vehicle will be analyzed for each and every regulation for the market which we are designing. So we have major design verification procedures for each and every market. Say for example, if it's an Indian market, we have all these DVPs like frontal crash, oil canning, side intrusion, offset impact, hood slam, door slam, and frequency and model analysis. So all these will be different, will have a different specification for different market. Say if you go for frontal impact in India, so we will be crashing the vehicle at a speed of 65 km/h. So at the same time, when you go for US, they will be crashing it at 60 km/h. And if you go for US, they will be crashing it for 70 km/h. So each and every standard is defined for each and every market. So if you want to sell your vehicle, you're designing a vehicle in India, but if you want to sell your vehicle in Germany, you're supposed to clear the frontal impact crash standard of Germany alongside of India. Okay. So when you're clearing both these standards, then only you will be able to sell it in German market. So that is how this works. So CAE is approximately 80 to 90% correlated with the physical impact relationships. So whatever we get in the physical analysis or physical validation of a vehicle, the CAE will correlate to 80 to 90% of the physical validation. So that is the reason majorly they try to close all the impact or deteriorating points in CAE, and we make the vehicle better to clear the CAE, and then we go for production. So next is the GNCAP. So this GNCAP or global NCAP is the test party or the national authorization party for any vehicle. So when a vehicle is going to be launched in the market, they take a vehicle after production to this testing center, and this test center should certify that the vehicle is good to be produced and sold in the market. So this test certificate will define a vehicle's credibility in the market, how safe the vehicle is for the passengers inside the vehicle and outside the vehicle. So if you see, recently we have made a few launches of Mahindra vehicles like Thar, Scorpio, and XUV 700. So, and all these vehicles we have cleared at a 5-star rating for a safety. Okay, so this 5-star rating defines that the vehicle is completely safe for the passengers inside. That is, the passenger can be rescued or saved with a minimal amount of injury. That is, this will keep the passenger alive. This 5-star rating doesn't mean the passenger will be 100% okay. That is, it says that the passenger will be 100% alive with a limited amount of injuries, such that he can come back to normal condition in a very short time after the accident or incident or anything. Okay, so that is the definition of this GNCAP standards and so on. So for further more details about GNCAP, you can go to their website. They have a fully defined standard for each and every physical validation, like side impact, front impact, and everything. Okay. So last but not least, this is one of my favorite quote, and it applies to all the students who are currently studying and who have completed your courses and you're looking for your job. So no additional skills, you become a choice to the employer. Skill up yourself so that employer becomes your choice. So when you don't have any additional knowledge or additional skills or additional hands-on training, always whenever you apply, the employer will consider you as just a last option. Okay, so you will be taken in only when they don't have any other choice. But when you skill up yourself, when you showcase that you are the best fit for the position which you are applying, then the employer will have no other choice rather than to recruit you at the first C of your resume than to go to the next employer or next profile or something. So keep this in mind, keep growing your skills. Don't stop at any point, because each and every day you are learning something new. Even I am learning something new daily. Okay.